Hello everyone, this is Ibrahim Sibgatullah over here. So if you have seen my previous video, I told you about this particular problem that we're going to do here. Alright, so in this particular problem, there is no torque that is directly given. Torque is given, but it is given indirectly. Okay, so in the previous problem, in the previous video, I have shown you a problem where the torque was given and probably that was quite easy for us to solve a problem like that. But in the question papers, they are also giving us questions like this type. Okay, they are not giving us what the torque is and they are not giving us what is the diameter of the shaft. Okay, but the good thing over here is that they are giving us the maximum shear stress and the angle of twist. But the angle of twist, as you can see over here in this question, it is given in 2 degrees. So I'll show you how we can convert this into radians to make it favorable for the general equation that we have. Alright, so starting with the question. A solid circular shaft of length 2 meters has to transmit a power of 200 kilowatts at 220 rpm. Okay, so what exactly does this sentence means? Okay, it means that there is a solid circular shaft whose length is 2 meters. Now this shaft is going to transmit a power of 200 kilowatts. And how will it transfer? It will transmit by rotating. And how much it has to rotate per minute? It has to rotate 220 revolutions. Okay, so over here 220 rpm stands for 220 revolutions per minute. Alright, then moving on, calculate the diameter of the shaft if the maximum shear stress is not to exceed 100 MPa. So whenever we are calculating the problem, wherever the maximum shear stress value is given, it should be taken as 100 MPa. So MPa stands for Newton per mm square. And then the angle of twist is also given. So as I just told you, angle of twist over here is given in degrees, but we have already learned that the angle of twist will be in radians. So we have to convert this 2 degrees into radians. And how can we do that? I'll show you when I am doing the problem. Then the maximum torque value is given. Okay, indirectly it is mentioned in the question that the maximum torque is 40% more than the mean torque. So whatever mean torque we are getting, we have to increase that with 40%. And then finally we have to the modulus of rigidity is also given. It is given as 80 kilonewton per mm square. Okay, the value is given as 80 kilonewton per mm square, and this is not a wrong value. This is the right value of modulus of rigidity. Sometimes it will be given like this. Sometimes it will also be given as GPa. So GPa stands for kilonewton per millimeter square. And how do we convert this? The conversion is very easy. Okay, so I'll show that to you very soon. Now let's start with the problem. And in the previous video also I have told you that whenever we are starting a problem, we have to start the problem by writing down, yes, whatever is given in the question. So starting with the first thing, the length of shaft, let's take it like that. L, it is 2 meters. Let's convert this into millimeter also. So 2 meters or 2000 millimeters. Next, the power is given P, and how much is it? It is 200 kilowatts. So to convert this from kilowatts to watts, the process is same, 200 into 10 power 3, and this will become watts. Okay, then the next thing is RPM. Okay, revolutions per minute, N. Okay, and that is 220 RPM. Okay, revolutions, number of revolutions per minute. Okay, I am representing that as N, and it is 220 RPM. Then the next thing is diameter of shaft is not given, but the maximum shear stress is given. So write it down, maximum shear stress Fs equals to 100 MPa. Okay, 100 MPa or 100 Newton per mm square. Okay, we can replace MPa with Newton per mm square. Next is angle of twist. Angle of twist theta is 2 degrees, but as I told you, we have to get this answer in radians. So what we can do, we can multiply this 2 with pi by 180. Okay, and this will get us an answer. That answer will be in radians. To convert degree into radians, we have to multiply it with pi by 180. Okay, so we have angle of twist, and then the final thing, which is modulus of rigidity. Modulus of rigidity, G equals to 80 kilonewton per mm square. So we can convert this as 80 into 10 power 3, converting kilonewton to Newton, Newton per mm square. This is what it is. And then in the end, before you start with the problem, just write down what is the general equation. Okay, so general equation is T by J equals to G theta by L equals to Fs by R. Okay, so over here, when it comes to finding out the diameter and when it comes to finding out the safe UDL on a beam or column, we are going to calculate these things using two cases. Okay, two different cases. So in the first case, we will calculate the diameter using strength consideration. Okay, we will start considering the strength, and that's how we will calculate the diameter. After we are done finding out, we will go into the next case where we will be calculating the diameter using the stiffness consideration. Okay, and then finally, whenever we are done calculating with these things, we will get two diameters, and whatever is the strong diameter, that will be the final diameter of what the question is asking us. All right, so let's start with the question. So let me just change the color of this. So I'm going with case 1. So in case 1, we are going to find out finding diameter from strength consideration. Okay, so from strength consideration means we have to consider the formula T by J equals to Fs by R. Okay, so now starting with T, the first thing that we have to find out is torque T. And what is T? We don't have what T is. Okay, so we will find that out using this formula that I have told you in the first video. Okay, to find out torque, the formula is P equals to 2 pi n TAB divided by 60. So over here, P is the power, N is the number of revolutions per minute, and TAV is the average torque. Okay, so P we already know what it is. It is 200 into 10 power 3 watts. So 200 into 10 power 3 equals to 2 pi n. N is number of revolutions, and that is 220. Then torque, average torque. Okay, that is what we have to find out over here, because the question says the maximum torque is 40% more than the mean torque. Okay, mean torque or average torque, whatever it is, divided by 60. Now let's cross multiply. So here we will get 200 into 10 power 3 into 60 divided by 2 pi into 220 equals to TAV. Okay, so now this answer 200 into 10 power 3 into 60 divided by 2 pi into 220, the answer will be 8. Sorry, let me write it down like this. Average torque or mean torque will be 8681.17, and the units over here will be Newton into meter. Okay, so to convert this into millimeter, we simply have to multiply this with 10 power 3 into 10 power 3 Newton millimeter. So this is the average torque. Okay, so in the question, what does the question says? It says maximum torque is 40% more than mean torque. Okay, so first let's find out what is the 40% of mean torque. So 40% of mean torque, this is what you have to do. Okay, whatever the mean torque is, 8681.17 into 10 power 3, you have to find out its percentage. So the easy way to find out percentage is 40 by 100. So I am getting the answer as 3472440. This is the 40% of mean torque. Now to find out the to find out the maximum torque, what we will do is, therefore maximum torque will be equals to what it is. It is 40% more than the average torque. So average torque into 10 power 3 plus it's 40%. Okay, 3472440. Okay, so the answer will be like this: 121.53610 Newton millimeters. Okay, I can also write this as P equals to 12.15 into 10 power 6 Newton millimeter. Okay, so we have got the first unknown of this formula. Now the next unknown is J. Now we can find that out very easily. Let me write it down over here only. Okay, J. So what is J? It is the polar moment of inertia that depends on how the shaft appears. Okay, whether it is solid or whether it is hollow. So if you have seen the question, it says that this shaft is solid. So pi d power 4 by 32. Now we don't have diameter, so let's just leave this as it is. Next is Fs. So Fs is already given in the question, and that is 100 Newton per mm square. Okay, the question says the maximum shear stress should not increase 100 MPa. So we are taking that value only. And then R. Okay, we have got T, we have got J, we have got Fs also from the question. Now when it comes to R, what is R? It is half of diameter. So we don't know what diameter is, so let's leave it as it is. Now we will substitute all these values back into the equation. So let's do that. Okay, so now what is T? T is 12.15 into 10 power 6 divided by J. J is pi d power 4 by 32 equals to Fs. Fs is 100 divided by d by 2. Okay, now either I can just directly cross multiply them on the other sides, but I'm not going to do that. Okay, I just want to make it more clear and simple to you all. So what I will do is I will first take a reciprocal of this. So 12.15 into 10 power 6 into 32 by pi d power 4 equals to 100 into 2 divided by d. Okay, this is how the reciprocal will be. Alright, so now let's send all numbers on one side and the alphabets on the other side. So 12.15 into 10 power 6 into 32 divided by pi into 100 into 2. And on the other side, we will write down d power 4 by d. So 1d gets cancelled over here and we will be left with d cube. Okay, so the answer now will be like this. Okay, the entire answer 12.15 into 10 power 6 into 32 divided by pi into 100 into 2 will be 618,794.41 equals to d cube. Okay, now in the next step, what I will do is I will send cube root on the other side. Okay, so it will be 618,794.41 cube root power of 3 equals to d. Okay, so now you already know how we have to find out the cube root from the calculator. If you don't know, I'll just show it in the camera. So over here where square root number is given, just above that in yellow color, there is cube root 3 given. Okay, so simply you have to press the shift button and you have to press that button and you will get the answer as cube root 3. I don't know if you are able to clearly see it, but yes, cube root 3. So cube root 618,794.41 will be, equals to 85.21 mm. Okay, sometimes what will happen is rather than cube, we will get power 4. Okay, so if you are doing something like that, then what you have to do is just above this button, okay, where we will press x power whatever value we want. Over here we have x square and x cube, but over here if the value is more than cube, then we will press this button. But slightly above this, there is a symbol like this. Okay, cube. Okay, whatever the power is, there is empty space over there. Then root is there, and inside also there is an empty space. So you have to press that and you have to press 4. Let's say there is power 4 or power 5 or power 6. So you have to press power, that much power, and then you have to press the arrow button. Okay, by the way, to select that thing, you have to press shift and that thing, then again add power, then after pressing power, just press the right arrow key, and then the cursor will come down where you can put your appropriate value. Okay, so now let's finish this case. Therefore, diameter as per strength consideration is D equals to 85.21 mm. Okay, so this is what it is. Now, this is not the diameter that we are looking out for. Okay, this is not the thing. This is not the last answer. Okay, this was just case one. There is one more case in which we are going to find out the diameter, and that case is with respect to the stiffness consideration. Okay, we will compare both of them and we will derive the answer. Okay, anyways, let's go into that case now. Okay, so moving on to case 2, calculating diameter using stiffness consideration. Okay, so when it comes to strength, we will have Fs value, but when it comes to stiffness consideration, we will be pursuing the angle wala formula. Okay, so what is the angle formula? It is T by J equals to G theta by L. Okay, so now we already know what T is from the previous step. So T is 12.15 into 10 power 6 Newton millimeter. Then when it comes to J, still, okay, it is a solid circular shaft. So pi d power 4 by 32. So again, now don't say that, just don't think that over this d we will replace the value from the previous step. No, that is not possible. Okay, we cannot do that. Let's just leave J as it is. Next is G. And what is G? It was 80 into 10 power 3 Newton per mm square. Alright. Next is theta. So theta we got, okay, we have derived the value of theta in the given step itself from before we started step 1. So it was 0.034 radians. Okay, and then finally length. The length was given as 2 meters or 2000 millimeters. Now we have the values, let's substitute them. So now what is T? It is 12.15 into 10 power 6 divided by J is pi d power 4 by 32 equals to G is 80 into 10 power 3 into 0.034 divided by L. L is 2000. Okay, now let's cross multiply the values. Now let us cross multiply the values. So this values will come here and these values will go there. Okay, so this will be 12.15 into 10 power 6 into 2000 divided by, acha, not, let's not do it like this. Okay, we will first take a reciprocal of this. I'll explain that to you in that way. Okay, let's not do the cross multiplication right now. Okay, so what we will do is we will first take the reciprocal of this denominator. So it would be 32 by pi d power 4. And then over here it will be as it is 80 into 10 power 3 into 0.034 divided by 2000. Now let's cross multiply them. So this will be 12.15 into 10 power 6 into 32 into 2000 divided by pi into 80 into 10 power 3 into 0.034 equals to this d power 4 would come out here. Okay, that is d power 4. Now let's solve this part even further. So upon solving, I have got the answer of this huge, okay, whole value. Okay, I have got the answer as 9 point, sorry, it is 9099179.23 equals to d power 4. So as I told you in the previous step, like how we can get the value of d power 4, this is 4 root, okay, this is not into 4, it is 4 root 9099179.23 equals to d. Okay, so what is the answer of d? It is 97.66 millimeters. So how did I got the value of d? Let me demonstrate that to you on the screen. So the first thing which I did was I pressed shift button and I pressed this button. So I have got something like this. Okay, then I will first write 4. Okay, I have written 4 over here. Then I will press the right arrow key and the cursor will come down. Then over there I will write down the value that I have got 90999.179.2 and equal to, and I am getting the answer as 97.66. Okay, 97.66 is the answer. Okay, then you just have to write down the sentence. Therefore, the diameter as per stiffness consideration is D equals to 97.66 mm. Okay, now what we have to do is we have to compare both the diameters. So we have one diameter as 85.21 and the other diameter is 97.66. Now from these two, what diameter will be the strongest one? Okay, I mean when the shaft uses which diameter, it will be the strongest. This one, okay, 97.66. If the diameter is 97.66 mm, then that will be the safe diameter of the shaft. So therefore, the safe diameter of shaft is D equals to 97.66 mm. That's it, guys. This is what the question was asking us to find out. Okay, calculate the safe diameter of shaft, which is 97.66 mm. Okay, so that's it. This ends this unit. Okay, you will be getting the problems in this particular way. So this is how the questions will be coming up. Regarding the derivation of this formula T by J equals to G theta by L equals to Fs by R, that derivation is 90% theory. Okay, and then there are some small calculations here and there. So for that, what you do is I'll be sharing the notes. Okay, the notes are there in the link which are given below. So what you have to do is you have to just simply press that link which is given over there in the description below. Okay, and if you click that, and that will open up a new folder where you will find the notes of this particular subject. Okay, everyone. So that's it for today. Thank you so much, and I'll see you with a very new video very soon. So till then, don't forget to subscribe to this channel and also don't forget to press the bell shaped icon. Okay, so thank you so much, everyone, and I'll see you all in the next video.